Hello everyone, this is Samaran Khalid and welcome to all of you on my YouTube channel. So guys, in this video we are going to see the third year BSc practical number 6 of the subject Python programming. Yes, so let us start the today's video guys. Before starting the today's video, if you do not subscribe to my channel, please subscribe it and press the bell icon so that you will get the latest update of the videos posted by me. Yes, so let's start the today's video guys. So this is our practical number 6 of the third year BSc mathematics of subject Python programming. So it is the application of the determinants and system of linear equations, guys. Yes. So guys, as we have seen in mathematics, there is a very tedious thing to find the determinant of 3 by 3 and 4 by 4 types of matrices. And again, it's tedious for some people for solving the system of linear equations, how we can solve this system of linear equations. Okay, so all of we know how we can solve and how to find a determinant in mathematics. So guys, in Python, okay, we have some methods. By using that methods, we can find immediately the determinant and immediately we can solve the system of linear equations. Okay, so this is the introduction guys, and this is practical of the third year, which is based on unit 4. And in this unit, so there is a point 4.4 and 4.5. These are the 2 points. So on these 2 points we will see this is the practical. Okay, so let us take the first question, guys. So explain the lean solve function with suitable example. Okay, guys. So this lean solve function in NumPy library also and in SIMPy library also. Yes. So NumPy is a big library and SIMPy is a sub library of NumPy. So lean solve is the both lean solve. This method is hold for both NumPy and SIMPy also. So we will see this in solving SIMPy. So it will solve a system of n linear equations with m variables. So both undetermined and overdetermined systems are supported. That means we can find any linear systems equations solution. Yes. So the possible number of solutions are 0, 1, and infinite. So when the zero solutions throws a value error. Okay. In Python, if the system has zero solution, then it will throw a value error to us in the output. And whereas infinite solutions are represented parametrically in terms of the given symbols. That means when our system has infinite solutions, then it will represent the output will be in parametrically and which is in the given symbols. And for the unique solution, we will get the finite set of vectors, and that is the order. It will be in order tuples, and it is returned. Okay, so I have given here some information about how we can solve these linear systems and how it will make. Okay, so these are the three equations. We can form their augmented matrix, and then we can write this system of linear equations into matrix form, and then augmented matrix Ax is equal to B. This is the equation, and then we can solve. Okay, so this is the method guys. I have given in detail. You can write it. Yes. So pause the video and you can write it and you can read it also. What is this? Yes. So you can pause the video and you can read it very easily. So we will take we have to explain this by example also. So I have taken the example. So it's in markdown itself. I will not going to take this example in code format because we have to see or we have to use this method in the next examples. Okay, that's why I'm giving this example in the code format. Sorry, markdown format. You can write this. So this is the example. From simply we have to import the matrix lean solve method and symbols also. Okay, so if we import this all these three functions, these are the three functions: matrix, lean solve, and symbols. These are the three functions in the simply library. So we have imported directly that three functions. Okay, if you don't want to import these three functions, we can simply import the simply library, add some abbreviation. We have given SP or SY, and then you can write whenever you need. You can write as SP dot matrix or SY dot matrix, SY dot insol, SY dot symbols. Okay. So, but when you imported already these functions from library, then there is no need to write abbreviation dot. That means SP dot matrix and SP dot linsol. Okay. So this is the method, or this is the thing that we have to remember. So we have to give the three symbols first, because we are going to see in uh, the system of linear equation into the three variables x, y, and z. Okay, so this is x, y, z, that is equal to symbols x, y, z. All of we known, yes guys, all of we know how to give these symbols to the matrix. Okay, that means x, y, and z, we have to define these symbols. Then we have to enter the matrix. This is the coefficient matrix, guys. So coefficient matrix of the system, and these are the coefficients of x, y, and z. Okay, so this is the first equation, that is x plus 2y minus 3, and this is the matrix B. B is equal to x is equal to B format, that is B, that is a 3. Okay, and then second equation is 4x plus 5y plus 6z is equal to 6, and so on. Okay, this is the matrix A and B. Then if we write A, so we will get the output as matrix 1 2 3 4 5 6 7 8 and 10. And if we give the B, then we will get the output as matrix 3 6 and 9. Okay, and if we write lean solve, yes, we have to give the syntax lean solve AB XYZ. Okay, lean solve AB XYZ. So this is the syntax for this method, guys. Okay, if you want to take the syntax, I'm going to take the new cell. Okay, you can write the syntax in this question itself. Okay, so what is the syntax? You can write it, syntax for the lean solve method. Okay, so how we can write it? So firstly, we have to give this import sp or import simpy. Then we can write it as sp dot. Okay, okay, 1 second. Sy dot, we are going to take the sy dot lean solve. Okay, lean solve, and in this lean solve you have to give the matrix or a system of equations. There are so many methods, guys, or there are so many ways. By using that ways, we can give the parameters or arguments to the lean solve function. Okay, so we have to give, for this in tuple, we have to give the matrix A or capital A, we are going to taken, that is the coefficient matrix, and this is the small b. Okay, that is the equal to side. And in this list, second argument is the list, and in this list you have to give the variables. That means how many variables your system have. Suppose we have given the three variables, that means our system have three variables x, y, and z. So this is the syntax, guys. Yes, so instead of this you can write expression also. Yes, expression in x, y, and z, and directly you can solve. So when we taken the example, then you will understood in detail. Okay, so let us move to the next question, guys. So this is our second question. So for matrix D is equal to, I have taken here 10, 2, and 3. These are the separate element. First row 10, 2, 3, and then 12 minus 7, 15 minus 15, 10 minus 11, and then we have to find the transpose of this matrix D, then determinant and inverse. Okay, if it is exist. Okay, so firstly I'm going to import the library, guys. Import simpy as sp. Okay, simpy as sy. Okay, now I'm going to take the matrix D or construct the matrix D. Okay, so D is equal to sy dot matrix function we have known, that is the matrix, and I'm going to construct the 3 by 3 matrix, that is a 10. Okay, there are so many methods, guys. If you don't seen the video of how to construct the matrix and how to import this library, okay, so please see that video. I have given the link of that video in the description box. Please check it and click the link and please see that video. Okay, so 10, and then 2, okay, and then 3. This is my first row, and I'm going to take now second row. Second row is element are 12, then minus 7, and then 15. Okay, these are the three elements. Now I'm going to take the third row. In this third row, this is the 15, and then 10 and minus 11. Okay, so these are the elements of my matrix, and if I'm taking the matrix D, so I will get the matrix D itself. Okay, guys, so I don't want the matrix D. Okay, so I want what I want, guys. I want the transpose of the matrix. So I will use this D dot T. Okay, D dot capital T. That means the transpose. So I will get the transpose of the matrix. Okay, so this is the transpose. That means the first row becomes the first column. See, 10, 2, 3 is the first row, and now here 10, 2, 3 is the first column. Okay, so if I will use the print statement here, okay, then it will be also give me the output, but the output will be, let us see what the output will be. Okay, how it is in the format, it is in the matrix format. Okay, so don't give the print statement, guys. Yes, don't give the print statement because it will not look like a matrix. Okay, so if we don't give like this, and if you give this one, so it will give you very nice output. Now the next one is we have to find determinant. Okay, there is a det method. So by using this method we can find, so d dot det, that means a determinant. So we will get the determinant of this matrix, that is minus 871. Okay, minus 871 is the determinant of the matrix. Now next one is we have to find the inverse of the matrix, right? Okay, there are two methods for finding the inverse. If it is exist, we have to find this question, find the inverse of the matrix D if it's exist. So when the determinant, oh sorry, when the inverse is exist, when the inverse is exist, if the determinant of matrix is not equal to 0, then the inverse is exist. Okay, if the determinant of matrix is not exist, then inverse is so guys, already we know. So here the determinant is exist. That means it is not equal to 0. So that's why its inverse is exist. So we will find the inverse of matrix D. That is a D dot inverse. Okay, D dot INV method. So by using this method, we can find the inverse of the matrix. So this is the inverse of the matrix, guys. Yes, very simple. Okay, so in mathematics, when we find the inverse of any matrix, then it will take minimum 5 minutes to find the inverse. Here it will take only 5 seconds to find the inverse. So this is the difference, guys. Okay, so now we can find D inverse by using another method also, D double star minus 1. Okay, that means D raised to power minus 1. And let's see the inverse method, inverse, and this double star minus 1 inverse, both are same. Okay, now let us move to the third question, guys. Okay, so in this third question we have given this matrix D, and we have to find a reduce, we have to reduce the matrix to row echelon form. Okay, and then we have to find the rank and the null space and column space. Okay, guys, so firstly we will import the SIMP library. Okay, import SIMP as SY. Okay, SIMP as SY, and then I'm going to take, so I have imported this one. Now I'm going to take the matrix as SY dot. Okay, so here we have to give the matrix as D is equal to SY dot matrix. So what is the matrix, guys? So we have the first row as 6, 18, and 3. Okay, so 6 and then 18 and 3. Okay, then second row, what is second row, guys? 2, 12, and 1. So 2, 12, and 1. And the third row, 4, 15, 3. Okay, so 4, 15, and 3. So this is my matrix D. Now I have to find the reduced row echelon form. So there is a method, guys, RREF. Okay, in the last practical we have seen that RREF, reduced row echelon form. So we will use that RREF. So RREF of this matrix D dot RREF. It is a reduced row echelon form. So we will get, this is the output, that is, this is the reduced row echelon form 1 0 0 0 1 0 and 0 0 1. Okay, that is the identity matrix, and it will give the pivot columns. Okay, first and two, that is 2. So what it will be, right? So if you want, you can check it. Okay, you can check it. Let us see. So it will return the reduced row echelon form of the matrix and indices of pivot variables. Okay, so this is the thing. Now we have to find the rank of the matrix D. So we will use D dot rank function. Okay, D dot rank function, and if we run this, so we will get the 3. That means the number of non-zero rows in the matrix in the reduced row echelon form. How many non-zero rows? 3 non-zero rows. That is the rank is 3. Then we have to write null space. So we will use D dot null space. So D dot null space. Okay, and run it. So we will get the null space as empty. And then D dot column space. Okay, so we will use this D dot column space. So what is the column space of the matrix D? So we will get, this is the column space of matrix D. It is a 6, 2 and 4, 18, 12 and 15, 3, 1 and that is 3. Okay. So this is the question, guys. Let's move to the fourth question, guys. So we have to solve the system. We have given this system 2x plus y is equal to 5 and x plus 2y is equal to 7, and we have to solve the system. So in the first question, we have seen the lean solve method. By using this lean solve method, we can find the solution of this system. So firstly, guys, we will import the library. So I'm giving the code in detail. Okay, import this MP as SP. Okay, as SP or S5. Okay, then we have to give the symbols, guys. Okay, so already in the matrix form I have given. So here are 3 examples. So I will give this example in expression format, the second one into the matrix format. So you can use any one. So SY, then we have 3 symbols, or sorry, 2 symbols. Okay, so I'm giving these symbols as x comma y is equal to sy dot symbols function. I have to use sy dot symbols. Okay, and how many symbols? 2 symbols, x and y. So I'm giving x comma y. Okay, sorry, x space y. Now I have to write the expression. Okay, so I will write this expression is equal to. Okay, so I'm writing this expression in a list. There are 2 expressions. So first expression is 2x plus y. So I'm writing this 2 into x plus y. Okay, and then equal to 5. That means minus 5. So I'm converting it to minus 5, comma. Second expression is x plus 2y. Okay, x plus 2 into y, and is minus 7. So this is the expression. Now I'm going to use the lean solve method on this expression. So I will use sy dot lean solve. Okay, lean solve. So I have to give in this lean solve methods 2 parameters. First one is the matrix, that means this expression, and second one is the variables. So I'm giving these expressions. Exp is my expressions. Okay, and then I have to give the variables x comma y comma z. Okay, and let's run it. So I will get, this is the solution 1 3 and z1, not z. I have to give only 2 1 because this is the 2 variable system. Okay, so it will give me 1 and 3. That means the value of x is 1 and y is 3. Okay. So this is the solution of the given system. Now, this is the fifth problem. So in this, we have given the three equations and three variables. We have to solve the system. X plus 2y plus 3z minus 3 and 4x plus 5y plus 6z minus 6 and 7x plus 8y plus 10z minus 9. Okay. So I will copy this code here. Okay. So now I will explain this by matrix method. Okay. X, y and z. Now here are the three variables. I'm giving x, y and z. Okay guys. Now we already know we can solve the system of linear equation by using the matrix method. That is ax is equal to b. So firstly we have to find the matrix A, that is augmented matrix. Sorry, that is matrix coefficient matrix. So I am writing here A is equal to, okay, this sy dot matrix. And then in this matrix, I am writing the coefficient of x, y, and z. So 1, then 2, and then 3. Okay, this is first row. Now second row, 4, okay, then 5, and then 6. This is the second row. And third row, 7, 8, and 10. Okay, so 7, 8, and 10. Okay. So this is my matrix A. Now I have to write the B matrix. That is AX is equal to B. So for the hint, I'm giving here AX is equal to B. Okay, AX is equal to B. Now I will take the B matrix as a small. Okay, B is equal to, again I have to write SY dot this matrix. Okay, and it's a column vector, na? So I will write into only one, this one, that is a 3, 6, and 9. Okay, 3, 6, and 9. Okay, so this is my matrix B. Now I will use the lean solve method. So what is lean solve method? So sy dot lean solve, okay, lean solve, and again in the tuple I have to give the matrix A and then B, small b. Okay, and then in the list I have to give the variables. So how many variables? X, y, and z. Three variables I have to give, and let's run it. Okay, 1 second. So what it will give, sy dot matrix. Yes, here I have to give the double square bracket. Yes, that's why giving it error. Yes, and now let's run it. So it will give me the solution, that is x is equal to -1, y is equal to 2, and z is equal to 0. Okay, so here already I have given the solution, that is import simply as sy and then xyz. Again I have written this into the equations. These are the three equations: 3x plus 2y minus z is equal to 3, 2x minus 2y plus 4z is equal to 6, 2x minus y plus 2z is equal to 9. So I have given all these equations into the one equation, that is one list, and then I'm using the sy dot lean solve equations and giving three variables x, y, and z. So I'm getting this 6 minus 11 and minus 7. Okay, guys. So I hope all of you understood this practical number 6 of the Python programming. So thank you for watching the video.